Gentlemen, this video is going to help you guys understand how to do the analysis of your lab. At this point, you should have inserted your data tables, okay, and inserted your graphs from the lab into your lab sheet. Okay, so we're moving on to doing the analysis. Okay, so in the analysis, the first analysis question says give 3 examples of unbalanced forces and 3 examples of balanced forces from the lab. Okay, so when we talk about balanced forces, okay, when we have balanced forces, our Hot Wheels are not going to be moving, right? So our little Hot Wheel is going to be stationary if the forces are balanced. Okay, so in our lab, hey, what did that look like? Hey, we had balanced forces when we had our car just resting here on the table. Okay, so why are those forces balanced? Okay, so those forces are balanced because we have a force down on the car and a force up on the car, right? So when we talk about the force that's up on the car, that's the force, it's called the support force from the table. And then the force down on the car is the force due to gravity, okay? And that's associated with the weight of the car. Okay, since the car isn't moving up and down, I know that those forces are balanced. Okay, I don't know if you guys saw it, but definitely I know when I watched some of the classes do the experiment, okay, our car ran across the table, right? So this is my little table here, okay, if you guys can watch, right? It ran across the table and then it got pulled all the way to the end of the table. When it got pulled all the way to the end of the table, it no longer had a support force, right? So the end of the table is here, okay? The car went off the table. It no longer has a support force, okay, of the table. Okay, the car falls. Okay, so the car's forces, or the forces on the car, go from being balanced to unbalanced when the car goes off the edge of the table. Okay, so there's your example of balanced and unbalanced forces associated with the gravity, okay, of the car, and then the support force of the table. Okay, when the car goes off the edge of the table, okay, there's no longer a support force of a table. The only upward force is some air resistance, and that's not enough to keep, that force is not great enough to actually hold up the car in the air, so the car falls down to the ground. Okay, another example of balanced forces. Okay, the forces are balanced. Okay, again, we were looking at the car. Okay, and the car, okay, the string attached to the car before I put any washers on it. Okay, when it was just the paper clip dangling over the edge. Okay, that paper clip didn't create enough force to actually pull the car to cause the car to move. Okay, so that would be an example of balanced forces, and that's looking at the forces to the right and to the left. Okay, in my case, the motion of the car, okay, for me, okay, is to my left. Okay, that means there's a frictional force, okay, that is to my right. Okay, so when I look at a car, okay, if it's got this string on it with the paper clip, that paper clip does not create enough pull to actually get my car moving. Okay, so my car will stay stationary. That's an example of balanced forces. So when I have my car with just the paper clip on the end instead of any washers added. Okay, so when I add my washers, okay, that's an example of when, okay, now the force on the end, okay, that pull is going to be greater than the frictional force. Okay, and that means that my car will start moving. Okay, my last situation, okay, in the last situation, I'm going to talk about part 2. In part 2, I add these washers to the top of the car. And when I add the washers to the top of the car, and I have 3 washers on the end of my paper clip, before the experiment starts, I have to hold on to the car. I actually have to hold it in place to keep it from moving. That's an example of balanced forces. Again, there's a pull on the car caused by the string with the washers attached to it. Okay, there's a frictional force, and there is this force of my fingers on the car. Okay, those 2 forces are preventing my car from moving, right? So there's a pull that's going to my left, and there is a frictional force and a force of me holding on to the car that's going to keep the car stationary. Okay. When I actually go to run the experiment, I let go of the car. Okay, so I release it. When I release it, you guys saw the car fly across the table. Okay, that would be an example of an unbalanced force. Okay, so those are your 3 examples of unbalanced and balanced forces. So you should use those examples or come up with some of your own, okay, from the lab for balanced and unbalanced forces for question number 1. Question number 2, I'm going to insert a force diagram. To insert a force diagram, I'm going to go up to Insert, Drawing, New. Okay, so if you missed that, go ahead, rewind. Okay, I'm going to insert Drawing, New. Okay, and then I'm going to start adding shapes. I'm going to use just a box to represent my car. Okay, so I have my car. Okay, that is here. I got a nice blue car. Then I'm going to start adding my forces that are on the car. Okay, and like we just talked about, there's an upward force on my car. Okay, that upward force on my car, I use an arrow, and then I'm going to add a text box to label it. Okay, that upward force is called the support force or the normal force. Okay, then there is a downward force on the car. So I'm going to get a down arrow. Okay, and that down arrow I'm going to place here. And since those 2 forces are balanced, I'm going to try to make those arrows as close to the same size as possible. Okay, so it's obvious that they are balanced. And again, I'm going to label that downward force. Okay, so that downward force is called the weight. Ooh, I can't spell this morning. Okay, weight, or you could say that's the force due to gravity. Okay, and then for my car, okay, again, I'm going to add another arrow, and I'm going to add a right arrow. Okay, that right arrow. Okay, if we're using this as my example, right, with my string this way, the force that's going to the right is going to be the force of friction. Okay, so I'm going to add a text box and label that force. Okay, and then my final force, okay, again, I'm going to go up to Insert Shape, Arrow. I'm going to use a left arrow. Okay, and once I release my car, okay, I have a pretty big force going in the opposite direction of friction, so my car actually will move. Okay, and that force, okay, that's going in the opposite direction is called the applied force. Okay, so the pull, okay, that's caused by the string with the washers on it, okay, the fancy name for that is the applied force. Okay, once you have that, you're going to save and close, and you'll see it inserts it right into my question. When you scroll down, the next question asks you, which forces from the diagram caused the car to accelerate? Okay, so again, there are 4 forces up here. Of those 4, what is causing the car to start moving or to start accelerating? And then are those forces balanced or unbalanced? So choose from those 4, which one causes the car to actually start moving, okay? And then is that force balanced or unbalanced? Okay, and then question 4 and 5, you're going to use your graphs to answer this question. Okay, so as mass increased, okay, this was part 2 actually of our experiment. So you're going to look at your data from part 2, and you're going to see as the mass of the car increased, what happened to the acceleration and why did that happen? And then question number 5 is actually related to part 1. Sorry, those are a little out of order. Okay, so in part 1, as the force increased, what happened to the acceleration? Did it increase, decrease, or was it not affected? Okay, and again, you're going to use your graph to determine that. Okay, then we get to identifying forces, and this is related to Newton's third law. In Newton's third law, it talks about that for every action, there's an equal and opposite reaction. Okay, so my example is I've got an action force. Okay, we've got a baseball as it bring a baseball to rest as it rolls across a field. Okay, well, the action force is the ball on the field, right? That's the applied force, the force that the ball is putting on the field. The reaction force is the force the field puts on the ball, okay, which in this case is friction. Okay, you're going to go through and identify action and reaction forces in each of those situations. And again, if you're not positive, like for this airplane liftoff, okay, I would put in, have a diagram, look for a diagram in Google that says airplane liftoff force diagram. Okay, let's talk about C. Okay, stop a car traveling at 25 meters per second. The action force is going to be the brake on the tire. Okay, and then what's the reaction force? Okay, so the reaction force is going to be the tire on the brake. Okay, so you see how one object is putting a force on the other object, but the reverse is also true. Okay, make a person begin to run from standstill. The action force has to do with your foot on the ground. Okay, and then the reaction force is going to be the ground on your foot. And for this one, I usually think about the idea of if you're running, right, you run on cement versus you run on the beach, which one's harder? Okay, it's a lot harder to run in the sand on the beach than it is to run on cement. Okay, and that's related to the action and the reaction forces. Okay, the last part of the lab is to write a conclusion. Okay, your conclusion, you're going to identify the purpose of the experiment. So in part 1, we were looking specifically how the force on the car affected acceleration. And in part 2, we were looking specifically at how the mass of the car affected acceleration. The second question, what did the data show or tell you? Okay, what evidence supports this? When you identify evidence, give me specific data points. So say as the mass increased from, let's say 34 grams to 42 grams, okay, the acceleration went from blank to blank. So give me specific data points that proves that that's what the data revealed. Okay, what did you predict would happen? What was your hypothesis in each scenario, part 1 and part 2? And then were you right? Okay, was your hypothesis accepted or rejected? Okay, one of the last things, what did you learn? Okay, and then if you did the experiment again, and those of you guys that are at home and didn't actually physically get to do the experiment, and looking at the experimental procedures, what would you do to actually improve the experiment? And I'll just tell you, there's one big thing, okay, which Mr. Hipley and I noticed when we were doing the experiment. We only did one trial of this experiment, okay? And as you guys know, multiple trials always make for better results, okay, because that allows you to eliminate errors. Okay, this experiment relates to the real world. Okay, so you might want to think about how different size cars might relate, or okay, how you would affect a car in terms of, you know, what kind of pull or push. Like for instance, my car has run out of gas before, and we think about, hey, what kind of pull or push would it take to actually get a car moving? Okay, if you didn't have any gas in it. Okay, so you might want to think about that, and maybe you can come up with some other examples of what the lab relates to. All right, ladies and gentlemen, I hope that helps you with the data analysis and the conclusion. Let me know if you have any questions. Have a great day.